A small ball of mass m is thrown upward with velocity u from the ground. The ball experiences a resistive force m kv², where v is its speed. The maximum height attained by the ball is the ball is moving with the velocity v. The resistive forces experienced by it are its own weight mg and the resistive force mkv². At the maximum height hm, v will be equal to 0 and the net force will be mass into acceleration. So at equilibrium, F net is minus mg minus mkv is equal to ma, where m is the same and a can be written as v dv by ds. So m cancels out and we'll shift the terms. After shifting the terms, we'll integrate. So height goes from s is equal to 0 to s is equal to h. ds is equal to minus 1 from v is equal to u at the bottom to v is equal to 0 at the extreme top of v dv upon g plus kv². This term can be integrated by the formula integration of x dx upon a plus bx², and this term becomes h max. So h max is equal to 1 by 2k natural log of g plus ku² upon g, or hm is equal to 1 by 2k natural log of 1 plus ku² upon g. So the correct answer is option 2.